Hello everyone, let's get started. In our previous video, we discussed about how an upcasting and downcasting basically works. And when you cast from one type to another type, it absolutely changes from to the type to which we are trying to cast it. For example, we had a very quick examples of two objects being created. One is for the base class object, another one is for our derived class object. And the examples we had are, we had a class called employee, and then we had a class called manager, which inherits the employee class. And we created two independent objects for two classes separately. For an employee class, we created an object name called AK, which is an employee class object. And for the manager class, we created an object called MN, which is a manager class object. And when we execute it, when you call that put function, that basically prints Ashok is an employee, which is the string argument which we are passing for that employee class. And when we call the put function from the manager class, it prints Ashok is a manager, Om Prakash is a manager. And when we cast it, when we typecast the base derived class object, that is manager class object, and that is being pointed by the employee class, here there happens a downcasting process, and the output what we get here is an Om Prakash is as an employee. Okay, and as a result of upcasting, we get an answer as Ashok is a manager. Okay, so this is the exact output which we received. So I'll run it one more time, and when you run it, this is exactly the output what we get. Okay, now this is the answer we have. Now what I want to show you is, I want to create two more functionalities. Talk about a virtual function. Okay, so in my employee class, I'm going to create a virtual function, virtual, with the keyword void vput. So this is the name of the function I'm going to create, and this does exactly the same action of the put functionality. So I'll again declare this function inside my manager class as well, void vput, but this time it prints as an manager. Yes. In that case, I can call up this vput function from the employee class pointer, and I can call this vput function again from the derived class pointer. I'll clear the screen. I'll compile the code once again. And when you run this, okay, let's have a look at the lines of execution. The first line, it prints Ashok as an employee because of the 61st line, the put function. Next line, it prints Om Prakash as a manager as a result of your 62nd line. And 64th and 65th line are the parts we have to concentrate on. 64th line, it prints Om Prakash as an employee because we have done a downcasting. So when we downcast, this Om Prakash was basically a manager class object. You remember? Om Prakash was a manager class object here. So it should have printed Om Prakash as a manager here, but it prints Om Prakash as an employee. Reason because we have downcasted it, and we are pointing that particular object is pointed by an employee class pointer. So it prints Om Prakash as an employee here. But if that is considered to be a virtual function, employee of vput, it retains the type of the object it is. The object type is being retained when that is a virtual function. And that same happens here in the derived class object as well. Here, Ashok is basically a base class object, and that is being pointed by a derived class pointer. Okay. Here, when I point it, I'm performing an upcasting here. So Ashok should become a manager when there is an upcasting that happens. So I'm upcasting it. But when I call the virtual vput function, it retains the type of the object it was. It was basically an employee class object. So that originality is being retained. That is the basic core purpose of the virtual function. Despite the kind of casting we perform, virtual keyword or the virtual function helps you to retain the type you were using it earlier, even though there is some override functionality that happens. And the quick definition of the virtual function is: a virtual function is a member function which is declared within the base class, and it is redefined or overridden in the derived class. When you refer a derived class object with the base class pointer, you can call a virtual function for that object and execute the derived class version of the function. Now, the advantages of virtual functions are: virtual function ensures that the right functionality is executed. Virtual function ensures that the correct function for the object is executed, regardless of the type of casting we perform in the code. They are mainly used to achieve runtime polymorphism, and in part of definition, the virtual functions are defined with the keyword called virtual in their base class definition. The resolving of the function call is done during the runtime. Now, there are certain rules for defining the virtual function. Number one, virtual function cannot be a static function. A virtual function can be a friend function of any other class. Virtual function should be accessed using pointers or references of base class type to achieve the runtime polymorphism. The prototype of the virtual functions should be the same both in their base class and their derived class. They are always defined in the base class and overridden in the derived class. And please make a note, it is not mandatory always for the derived class to override the base class virtual function. In that case, the base class version of the virtual function is being retained. A class may have a virtual destructor but not a virtual constructor. Reason being is, constructor should possess the same name as the class name, so there is no possibility for us to have a virtual constructor, but it is possible for us to have a virtual destructor. Now, this is a very common question which is being asked during their technical HR interviews. Can we have a virtual constructor? The answer is no, we cannot have a virtual constructor. Reason because the first very thumb rule of the virtual function is nothing but the prototype of the virtual function should be same both in the base class as well as the derived class. That is, it has to have the same signature in the base class declaration as well as the derived class declaration. And when it comes to constructor is a function which has the same name as the class name. So there is an obvious chance of the constructor to have different names in the base class as well as the derived class. So that overlays with the first primary thumb rule of the virtual function where the signature has to be same. So using this criteria, we can very well surely say that there is no possibility to have a virtual constructor in place, but it is possible to have a virtual destructor. And last but not the least, we have yet another functionality to talk about, that is nothing but pure virtual functions. Now, pure virtual functions are pretty simple. For example, we have our base class, and in the base class, we create a virtual function, but we said that function has no, and that is assigned to a value of 0. In that case, this particular base class, employee class, becomes an abstract class which has a pure virtual function, and this is the declaration of your pure virtual function. And the only thing is, you cannot create objects for the class which contains a pure virtual function. Reason because this class becomes an abstract class. Any class which possesses a pure virtual function becomes an abstract class, and there are no objects you can create for your abstract classes. As you come down here, this way of creating objects for your employee class is not possible. So what I need to do is I have to typecast it and create a new object here. So here I'm calling the new employee class with the name of Ashok, and then I can perform the typecasting here. So this typecasting is not allowed. I cannot create these lines as well, as you cannot create objects for the base class. Okay, so I've deleted those lines, and when I compile, run this up, compile this, I'll run this again. It prints Om Prakash as a manager, and it prints Om Prakash as an employee. Reason because of the casting that has happened here. MN put or else EMP put. I have casted my manager class object to an employee class object. I have made a downcasting process, and when I call the virtual function, it retains the derived class type. That is, Om Prakash becomes the manager because it was originally, when I declared, I made the object MN as the manager class object, and it is fixed. You cannot create objects for your abstract class which contains a pure virtual function. or any class which contains a pure virtual function is basically an abstract class, and creating objects for the abstract class is not possible in C++ programming. And I hope the idea of virtual function and the pure virtual function is very clear to all. See you in the next part of the video. Until then, happy learning and happy coding.